Part 5. Colour differences and tolerances. When you measure colours, you often do so to objectively confirm that your product meets a certain reference colour or target. As a producer, you want to keep the colour difference to this reference colour as small as possible. But what difference can be considered good enough? And how can you agree on colour specifications? Understanding the concepts of colour differences and tolerances will help you to avoid wasting material and time, often to the direct benefit of profitability and productivity. Colour differences allow us to utilise colour measurement data to express the difference between two colours. They can be used to express the difference in one or multiple colour indexes and to communicate the degree of difference and the nature of the difference between two or more samples. The most commonly used colour space for expressing a perceived colour difference is CIElab. Using the CIE's L star, A star, B star axis, it's possible to express each of the axes in terms of difference, for example, plus or minus L star. The illustration on screen shows a visualization of difference in a blue colour, entirely on each of the axes. First, lightness, with the target colour in the centre. Next, the A star axis, and finally the B star axis. The overall colour difference is commonly expressed as a delta E value, which is a cumulative expression of the difference in all three axes, L star, A star and B star. In other words, delta E will give you one value to indicate how large the colour difference is. However, the delta E value does not tell whether the sample is lighter, darker, bluer, redder, greener or yellower. Delta E allows the device or the operator to quickly evaluate pass or fail of a sample colour against a target with a single metric, often to prompt more investigation, further measurements or corrective actions. Colour differences and tolerances do not always relate to the perceived colour during colour quality control. For example, if you're measuring the roast level of coffee beans, you're not necessarily interested in whether the beans look pleasing. The colour scale here corresponds to how the coffee will taste, and this is why many industries will have their own indexes or scales, each expressing colour in terms of what is relevant to their specific application. Adopting specific scales, which are sometimes less linear than delta E values, or contain a whole range of colours, can help producers to leverage the benefits of traceable colour data more widely in their processes. Examples of industry-specific indices and scales could include US and European pharmacopoeia, whiteness indexes such as CIE whiteness, yellowness indexes, light reflectance value, and specific food indexes are available for things like peanut butter, tomatoes, eggs and coffee. Once you've selected a suitable colour difference index, you're ready for the next step. You can set colour tolerances on your product or products. Tolerances are an important balancing act between supplier and brand owner or customer. Setting too tight tolerances can greatly increase the cost, time and waste of production, sometimes to achieve returns that would not be noticeable to the customer or end user. If the tolerances are too wide, however, products that the customer or consumer would consider sufficiently different make their way into the market and can damage the reputation of the producer or relationships within the supply chain. Establishing tolerances typically involves gathering a number of production samples to separate the acceptable and non-acceptable samples and measure them in order to quantify the colour difference, its severity and direction. If the variation in colour will not meet the customer's expectation, the producer may lose their order or have to lower prices. The exercise of setting tolerances can sometimes reveal that colour difference is more acceptable or indeed more noticeable in one axis than the others. For example, in cornbread, a shift towards yellow may be more acceptable, while it should not be lighter. Some considerations may facilitate a tolerance that could be easier and more repeatable for production while still assuring the right quality. Similarly, the importance of colour accuracy of all parts is not necessarily equal, and the feasibility of colour accuracy on other parts is simply not physically or economically viable. Setting and agreeing upon tolerances requires a close collaboration between parties. The ambition of the collaboration should always be in the best interests of both parties, supported by documentation and with a clear process of how samples should be assessed and measured. You can start by considering the repeatability of production, the colour vision score of the assessors and stakeholders present, assessed with something like the Munsell 100 test, the repeatability of colourants from your own suppliers, how important it may be to balance other properties like light fastness or indeed cost. You should operate under best practice visual assessment conditions using a light cabinet, angle table, and probably more than one illuminant. You should agree on an instrumental measuring solution, the approach for measuring, and a maintenance schedule. You should know how repeatable measurements are, especially if the product has a complex surface. You should agree on a process for rejects and QC. This way, any disagreement over samples being in or out of tolerance in the future can be avoided or resolved without subjectivity.